Guys, let's look at this problem right here. This question is asking one side of a fish tank is built using a large aperture thin lens made of glass. The lens is equiconvex with radii of curvature 30 cm. A small fish in the tank is 20 cm from the lens. Where does the fish appear when viewed through the lens? What is its magnification? Okay, now let's begin with the equation. First we are going to apply the equation of the curved surface. Okay, curved surface of the lens. So if we use the left surface, the equation for the left surface is going to look like this: n1 over s1 plus n2 s1 prime is equal to n2 minus n1 over r1. Okay, s1 is the object distance and s1 prime is the image distance. Okay, and r1 is the radius of curvature, and that's it, right? Now also for the right side, this, let's say this is equation 1. For the right side we are going to have n2 over s2 plus n3 over s2 prime is equal to n3 minus n2 divided by r2. This is equation 2. Now from this one we can say that s2 is equal to negative s1 prime. s2 is equal to negative s1 prime. So we can replace this value in the equation 2, right? So in the equation 2, if we replace this s2 with negative s1 prime, the equation is going to look like this. We are going to have n2 over negative s1 prime plus n3 over s2 prime is equal to n3 minus n2 over r2, and this is going to be our equation 3. Now what we are going to do is we are going to add this equation 3 and 1 together, and if you do that, this will become, okay, I'm adding 1 and 3, and if we add them together, that's going to become n1 over s1 plus n3 over s2 prime is equal to n2 minus n1 over r1 plus n3 minus n2 over r2. So this is our equation 4. And also we can say that s2 prime is equal to s1. Okay, because now we are considering the whole system. So we replace this s1 with s, and also we are going to replace this s2 prime with s. So in that way we will have an equation like this: n1 over s plus n2 over s equal to n2 minus n1 over r1 plus n3 minus n2 over r2, and this is going to be our equation 5. Okay, now we are going to do the sign convention for the radii of curvature, and if you do that, that's going to become, let's say, equation 6. Let's use a different color. So this is going to become n1 over s plus n3 over s is equal to n2 minus n1 over r1 plus n3 minus n2 over negative r2, and this is going to be our equation 6. Now we can go ahead and plug the values, and we know that n1 is equal to 4 by 3, and then divided by 4 by 3 divided by 20 centimeter plus 1 over s prime is equal to 1.5 minus 4 over 3 divided by 30 centimeter plus 1 minus 1.5 over negative 30 centimeter. Okay, here our purpose is to find out the distance of the fish, that's s prime. So appearance distance, that's s prime, and if you solve for this one, that's going to give us negative 22.5. Now the next question is asking for the magnification, and magnification for the system is given by this equation: ms is equal to m left times m right. Okay, m left equation is going to look like this: nl times s psi, actually s1 prime, over n2 s1. Okay, so this is the left side, and also for the right side we are going to have nr, or we can say n2 s2 prime over n3 s2. Okay, so we have to multiply these two together in order to create the system equation for the magnification. Let's use a different color. So s is going to be multiplication of these two. If you multiply and simplify these two together, that's going to give you negative n1 s prime over n3 s. And now we can go ahead and plug the values. This is going to be negative 4 divided by 3, and then we found out the distance of the fish, that is negative 22.5 centimeter divided by 1 time 20 centimeter, and that's going to give us 1.5, and that's going to be the magnification. I hope this helps. Thanks for watching.